Hi students, welcome to MC Square video classes. In this video class, we are going to discuss about short answer questions who appear in model papers. The separate video is there for 2 marks questions as well as 8 marks questions. This one is exclusively for 4 marks questions, short answer type. So whatever the questions are there in the model paper, question to answer we will discuss in this class. So the first question has given that deduce Charles' law, Graham's law of diffusion from kinetic gas equation. That is the question. Okay. So what is kinetic gas equation? PV is equal to 1 by 3 mn URMS square. This is called kinetic gas equation. If you don't remember this, you can't answer this question. Okay, definitely you should remember this. PV is equal to 1 by 3 mn URMS square. P is pressure, V is volume, M is mass of one molecule, N is equal to number of molecules, and URMS is what? RMS speed of gas molecule. Here, a simple point, remember that if N is equal to Na, N is what I told, number of gaseous molecules, Na is what? Avogadro number, means number of molecules is equal to Avogadro number. Then what will happen? Then mass into Avogadro number. I'm talking about only these two things. M into N, in the N place we wrote what? Na. Then mNa is equal to molecular mass of that gas molecule, that is capital M. Okay. Based on this, we can write in the next step, PV is equal to 1 by 3. In the place of Mn, we can write what? M URMS square. This next step, PV is equal to, you can write 2 by 3 into 1 by 2 MURMS square. If you observe that here 2 and this 2 will get cancelled, you will get 1 by 3 MURMS square only. And this formula resembles what? This formula resembles kinetic energy formula. Kinetic energy is equal to half mv square. M means what? Mass. V means what? Velocity. Here also M is what? Mass only, molecular mass. And U means what? Velocity. Which velocity? RMS velocity. So we can write this half mv square is equal to kinetic energy. So based on this, PV will become what now? PV is equal to 2 by 3 KE. In the place of that, you can write KE. But from the kinetic theory of molecular gases, we know that. So we know that kinetic energy is always directly proportional to absolute temperature. We know that, right? So Ke is equal to what from this? Ke is equal to constant will come, constant into T. That is K into T. So in the next step, what will happen now? PV is equal to 2 by 3 KT. V is equal to what from this? V is equal to 2 by 3. We have to send this P to the right side. Here multiplication, here division will become K by P into T. So 2 by 3 is the constant, we know that. K is also constant. At constant pressure, we are assuming that pressure is constant. Then total will happen what? V is equal to, this total is constant now. So constant into T. Then you can write this as what? V is directly proportional to T. Correct? Constant into T is nothing but what? Directly proportional to T. V is directly proportional to T. This is known as, so this is Charles' law or Charles' law. Finished. Very simple, right? This is Charles' law. A completed. Now one more law he asked that what? One more law, Graham's law of diffusion. We'll try to do that. Graham's law of diffusion. Graham's law of diffusion. So here also we will take the same thing from kinetic gas equation only. So from kinetic gas equation. So definitely you should remember this kinetic gas equation. Without that you can't answer this question. Sometimes they may ask you that deduce Dalton's law of partial pressure, and one more is Boyle's law. So most of the times they will give questions from that. Any two they will ask for 4 marks. So try to remember and try to remind those two also. Here PV is equal to what now again? PV is equal to 1 by 3 mn URMS square. PV is equal to 1 by 3 mn URMS square. Here URMS square same as the before. Then what will happen here? This thing. Next we can write this directly. I am writing PV is equal to 1 by 3 m URMS square. We can write this from this. That is why I am not writing anything here, right? Now from this URMS square is what? Otherwise you do the cross multiplication. 3 PV is equal to m URMS square. 3 PV is equal to m URMS square, but we want URMS square. URMS square is equal to 3 PV by m. 3 PV by m. So here pressure is constant, of course. URMS square is equal to 3 PV by m. We know that mass by volume is equal to density, right? The mass per unit volume is called density. But we have here what? V by m. M by V is D, means V by m is what? 1 by D. So URMS square is equal to 3P by D, because V by m is equal to 1 by D. 3P into 1 by D is 3P by D. URMS is equal to, from this, URMS is equal to what? Under root 3P by D, correct? So pressure is constant. At constant pressure what will happen? URMS is equal to constant into 1 by root D, right? Then what will happen? URMS, same like this, V is equal to constant into temperature. So V is proportional to T. In the same way URMS is proportional to, that is inversely proportional to, square root of density. So this speed of gas molecules is nothing but rate of diffusion. So finally, therefore R is rate of diffusion. R is inversely proportional to square root of density. So this is called what? This is Graham's law of diffusion. This is called Graham's law of diffusion. That's it. Okay, very simple, right? If you remember that kinetic gas equation, to answer this question is very, very easy. We'll go for the next question now. Hope all of you copied this. 12th question. It has come from stoichiometry. Whenever you listen this word stoichiometry, definitely you will get that important questions in that is balancing equations based on ion electron method, right? Very, very simple. Ion electron method, that question is most important. Acidic medium and basic medium, both you have to go through. One, either acidic medium or basic medium. So in this model paper, they gave basic medium. We have to balance that equation, that redox reaction, based on ion electron method, right? I am writing that equation first. That equation is MnO4 minus MnO4 minus plus I minus okay, gives rise to MnO2 plus I2. This is the question asked. Based on which method is asked? Based on which method means ion electron method. This is basic medium, first of all. Basic medium, that also given in the question, right? Basic medium. And method is what? Ion electron method. So the rules, you know that. Again, I will remind you what are the rules for basic medium or acidic medium, both. Now this question based on the basic medium, right? So the first thing, either acidic medium or basic medium, we have to calculate the oxidation states of central atoms and each and every substance here in the redox reaction. So try to calculate manganese oxidation state here. So manganese, we have to take that as X plus 4 oxygens are there, each oxygen is -2, is equal to whatever the charge is there, that is -1. So X plus into minus, 4 2s are 8 is equal to -1. X is equal to -1 plus 8 is equal to +7. So the oxidation state of manganese is here is +7. The oxidation state of I, whenever that uncombined element is there, right? If charge is equal to its oxidation number. So I minus, that is why oxidation number is -1. Now try for this MnO2. Mn is X plus 2 into, for oxygen I told you that -2 is equal to, here charge is not there, that is why equal to 0. X plus into minus 2, 2s are 4 is equal to 0. X is equal to +4. So this is +4. And I2 is that uncombined molecule. So uncombined molecules and uncombined element will get oxidation number 0. So oxidation number of this is 0. Now the important thing is, this is redox reaction. Redox reactions means what? Simultaneously both oxidation and reduction will occur, right? Now we have to divide that redox reaction into two equal halves. What are those? Oxidation half reaction and reduction half reaction. Oxidation half reaction means where that oxidation number increases. If you observe that manganese and this manganese, the left side manganese contains oxidation number +7, right side manganese contains oxidation number +4. Means what? Oxidation number decreases. That is called reduction reaction. If you observe iodine, here -1, here 0. Means what? -2, 0. Oxidation number increases. That is called oxidation half reaction. So we divided them into two equal halves. One is oxidation half reaction. Another one is reduction half reaction. Oxidation half reaction. OHR means oxidation half reaction and RHR means reduction half reaction. Oxidation half reaction means where that oxidation number increases, that is I minus gives rise to I2. This is oxidation half reaction. Reduction half reaction is what? MnO4 minus gives rise to MnO2. Okay, so this we have to balance both separately, then we have to add them. That is the concept, you know that. First we have to balance. The first rule is balance the atoms other than oxygen and hydrogen. So other than oxygen and nitrogen means here I only is there, iodine. Here two iodines are there, here only one iodine is there. That is why we are multiplying this iodine with 2. Then both them equal. Here I2. Here 2 iodines, here also 2 iodines. Correct? Here balance the atoms other than oxygen and hydrogen means only manganese is there. Manganese already balanced. Here manganese, only one manganese is there. And here also only one manganese is there. Right? Next, try to balance oxygen and hydrogen. Here no oxygen, correct? So no need to balance this. Here oxygens are there. Left side 4 oxygens are there. Right side 2 oxygens are there. If you compare right side, deficiency of oxygens is there. Wherever the deficiency of oxygens are there the same number of water molecules. For example, 2 oxygen deficiency means 2 water molecules. 1 is there means 1 water molecules. 10 is there So if we compare this left and right side we have deficiency of 2 oxygens, that is why we have to add 2 water molecules at right side of this reduction of reaction, MnO2 plus 2 water molecules, finished. Then balance the hydrogen atoms. Here no hydrogen atoms, no need to balance. Here hydrogen atoms, how many are there? 4 are there, right? Where the deficiency of hydrogens are there we have to add same number of H plus ions. What is the reason or acidic medium? The basic medium difference, very important. Whenever we are adding H plus ions either left side or right side, the same number of H minus ions also will be added both the sides. What is the point? So here we have to add 4 according to this. Okay. MnO4 minus plus 4H plus. Just now I told you that whatever the number of hydrogen atoms we are adding, the same number of OH minus ions also will be added both sides. So 4OH minus. And that 4OH minus will be added at the right side also. That is the rule to balance basic medium, right? So 4OH minus. Now here nothing is there to balance except electrons, correct? Here how many electrons are there? For 1 iodine, 1 electron, 2 iodines, 2 electrons. Here there are no electrons, 0 electrons, correct? Here 2 electrons extra are there. Here 0 electrons. So where the deficiency of electrons are there? Right side or left side? Right side. So right side we have to add 2 electrons. 2I minus gives rise to I2 plus 2 electrons. So this oxidation of reaction is completely balanced, no need to touch it again. Now come to this right side, that is reduction of reaction. Here 4H plus 4OH minus will become what? 4 water molecules, because 1 H plus and 1 OH minus means what? 1 water molecules. 2H plus 2 OH minus means what? 2 water molecules. Now we have 4 H plus and 4 OH minus, we can write that as 4 water molecules. 4H2O gives rise to MnO2 plus, as it is you can write remaining part 2H2O plus 4OH minus. Now everything are balanced here except electrons. Now same like this we have to write the electrons. Here how many electrons are there? 1 electron. Here 0 electron. Here 0 electron. Here also 0 electron. Here 4 electrons. Observe that 4 electrons, right? So left side how many electrons are there? 1 plus 0 is equal to 1 electron. Right side how many are there? 0 plus 4 means 4 electrons. Where the number of electrons are more? Right side. Right side 4 electrons are there, left side only 1 electron is there. So right's deficiency of electrons are left side. When compare with right side, how much deficiency of electrons are there? 3 electrons are there. Those 3 electrons we have to add left side. That is the point. MnO4 minus plus 4H2O plus 3 electrons gives rise to MnO2 plus 2H2O plus 4OH minus. Got it? Now everything are balanced. You can observe here 1 manganese, here 1 manganese, here 8H, right? Here 2 2s are 4 plus 4, 8. Here also balanced. Oxygens 4 plus 4, 8. Here 2 plus 2 plus 4, 8. Electrons here 4, here also 4. In the same way, this also balanced. Now we have to add both of them, OHR and RHR. So the point is here, whenever we are adding OHR and RHR, we have to add them in such a way that both should get same number of electrons. Here for OHR we have 2 electrons and RHR we have 3 electrons. So to balance them, we have to multiply this OHR. I am multiplying OHR with 3 plus I am multiplying this RHR. If you multiply OHR with 3 means 3 2s are 6 electrons. Here 3 electrons are there. We have to make that 6 electrons, means multiply with which number? right, 2. So this we have to do now. OHR into 3, what will happen? OHR into 3. 3 into this, correct? 3. Here this into 2. 3 2s are 6. 6I minus gives rise to 3 into I2 is what? 3I2 plus 3 2s are 6. 6 electrons. Now this into 2. 2 MnO4 minus plus 2 4s are 8. 8 water molecules plus 2 3s are 6. 6 electrons. Gives rise to remaining part 2 MnO2, 2 into MnO2, 2 MnO2 plus 2 2s are 4, 4H2O plus 2 4s are 8, 8OH minus. Now we have to add both of them. So the final answer will come. Here 6 electrons and 6 electrons will get cancelled. Remaining part we have to write as it is. So what we have here? 6I minus, here I wrote, plus 2 MnO4 minus. Now the next point you observe carefully here, 8 water molecules are there 4 water molecules are there. Wherever the number of water molecules are more or number of substances are more, from there we have to subtract the number of least molecules. So here 8 are there, here 4 are there, means 8 minus 4 will become what? 4. 4H2O. So left side everything completed. Right side now 3I2 plus 2 MnO2. Water already we subtract from that, right? And remaining part is what? 8OH minus. So this is the balanced equation. If you want, you can check how many iodines are there left side? 6. Right side also 6. Manganese left side 2. Right side also 2. Oxygens left side 8 plus 4 12. There 4 plus 8 12. Left side hydrogens 8. Right side also 8. Electrons, here 6 electrons plus 2 electrons 8. There also 8 electrons. So including electrons, everything are balanced. Very important. The basic medium, the only difference is whenever we are adding H plus ions, the same number of OH minus ions we have to add both sides. In the acidic medium, that won't required. Okay. So that's about the 12th question. We'll go for the next question. 13th question. 13th question has given from that what is conjugate acid base pair? Write the conjugate acid and conjugate base of each of the following. That is the question given. So this question, the 13th question, from where you can guess that conjugate acid base pair means that question has come from acids bases. That is chemical equilibrium, acids and bases. From that topic, that question has given for 4 marks. So 13th question is what? What is conjugate acid base pair? Conjugate acid base pair. He is asking that first question is what? Conjugate. What is conjugate acid base pair? And the question continues like that. Try to remember, I'm not writing the question. Write the conjugate acid and conjugate base of each of the following. What are those each? He given that A, OH minus, and B given that B is HCO3 minus. Okay. So for these two, we have to mention what will be the conjugate acid. First, conjugate acid base pair means what? The acid base pair which differ by only one proton or single proton or H plus ion is known as conjugate acid base pair. Means two species are there, right? Both should be differ by only one proton. Okay. For example, here I am writing AH minus and H2A. If you observe that the difference is what? 1A, 1A. 1 hydrogen, 2 hydrogen. What is the difference? 1 proton, 1 H plus. So these two are called as what? Conjugate. Okay. For example, I am taking here AH2 and here also H2A. Now protons are same. This is not called as conjugate acid base pair. Otherwise, I am taking here 3. Now 3 minus 2, 1. Difference is only 1, that is why conjugate acid base pair. Just for example, I am taking. Here H4A for example. Now what? The difference is what? 2. So this is also not conjugate acid base pair. So conjugate acid base pair means acid base pair differ by single proton. Very simple. So we can write the same, the acid base pair. The acid base pair which is differ by means the difference differ by only 1 proton. Proton is nothing but here what? H plus proton. The acid base pair in which is differ by only 1 proton is known as conjugate acid base pair. Conjugate acid base pair. Okay. So half of the question completed. What is conjugate acid base pair? We define that. The next question continues that what? Here we have to write conjugate acid for this and conjugate base. For this also conjugate acid, conjugate base. So here species given that A is OH minus, B is HCO3 minus. Species we have taken whatever given in the question. Now we have to write this what? Conjugate acid we have to write and conjugate base also we have to write. Conjugate base, both we have to write, conjugate acid and conjugate base. Very simple. Whenever we are trying to write the conjugate acid, we have to add 1 proton. Try to remember this. Whenever we are trying to write the conjugate acid means we have to add 1 proton. So opposite conjugate base means what? We have to remove 1 proton. Correct? So what is the conjugate acid for this? Try to answer. We have to add 1 H plus means what will happen? Plus minus will get cancelled. Right? H, 2 H are there, H2O it will become. Now what is the difference here? The difference is only 1 H plus, correct? But why we are calling that acid? We are adding H plus. Okay, according to Bronsted acid base theory, proton donor is acid, right? And proton acceptor is base. So here conjugate base means from this we have to remove this H plus. Then what will happen? It will become O. Already 1 minus is there and 1 more. H plus we are removing means 1 more minus will come. O minus 2. This is the conjugate base. Okay. HCO3 minus. Now we have to conjugate acid means what? We have to add H plus. So whenever we are adding, what will happen? HCO3 will become H2CO3. Correct? Conjugate base. Try to answer. Pause it and try to answer. HCO3 minus. We have to remove 1 H plus. Correct? So CO3 minus already there. 1 more H plus we are removing. That is why 1 more minus will come. So that will give CO3 minus 2. That's it. Very simple, right? So define and this you have to write. Very, very simple. Try to practice them. You have so many examples in the book. Better to practice. They may give anything. If you practice, whatever the species they have given, you can answer. Conjugate acid means we have to add H plus. Conjugate means we have to add, we have to remove H plus. Whenever we are removing H plus, 1 minus will come extra. That is the only thing. Okay. So that's about the 13th question in the section B. We'll go for the 14th question. So the 14th question is, explain the following with suitable examples. That is the question. Explain the following with suitable examples. What are those? Electron deficient hydrides, ionic hydrides. Okay. 14th question is coming from, what is the topic? Can you guess? Hydrogen and its compounds. In hydrogen and its compounds, we will discuss hydrides, isotopes of hydrogen, and compounds of hydrogen, that is water, heavy water, hydrogen peroxide, right? So anyway, in this question he has given that hydrides, A is electron deficient hydrides. Electron deficient. He is asking that explain the following with suitable examples. Hydrides. Electron deficient hydrides. What are electron deficient hydrides? So for example, here B2H6 is there. What is this? You know that, very famous, diborane. So for this diborane, whenever we are writing the structure of diborane, we are writing like this. BH3, for example, one part we will take. One part, BH3 means what? B, here hydrogen, hydrogen, hydrogen. Okay, usually this will form in the dimer. Just for understanding, I am telling as BH3. This boron surrounded by how many electrons? One bond means 2 electrons. How many bonds are there? 3 bonds are there. 3 into 2, 6. 6 electrons are there. Still it required how many electrons to get octet configuration? 2 electrons. 6 plus 2, 8. Means what? The availability of electrons is how much? 6. Still we required how many electrons? 2 electrons. So whenever the hydrides are having less number of available electrons than required are called electron deficient hydrides. Very simple. Okay. So the example also you can take the diborane coming from the 13th group elements. How can you define this? So the hydrides, as I said, number of available electrons, the hydrides which have less number of available electrons, than what? Required, than required number of valence electrons. Required number of, here also valence electrons. Required number of valence electrons are known as what? Are known as electron deficient hydrides, are called electron deficient hydrides. Electron deficient hydrides. Very simple. Now we have to give one example. Okay. What is the example? Just now I discussed. Example is what? The hydrides of 13th group elements. The hydrides of 13th group elements like diborane. What is diborane formula? B2H6. Finished. The hydrides of 13th group elements like B2H6 are known as electron deficient hydrides, which are having less number of available valence electrons compared with required number of valence electrons. Okay. Now next, one more given that ionic hydrides. Ionic hydrides. What are ionic hydrides? So the simple ionic hydrides means the hydrides which are formed from the highly electropositive elements. What are highly electropositive elements in the periodic table? S block elements. What are S block elements? First A and second A groups. Those hydrides are called ionic hydrides or salt-like hydrides. Okay, the another name of that is what? Salt-like hydrides. So you can say that the hydrides which are formed by the highly electropositive elements, simple, are called ionic hydrides, also known as what? Just now I told you, ionic hydrides or salt-like hydrides. Why? Because those are combined with metals. That is why salt-like hydrides. Example again. Just now I told you which groups. So the hydrides of which group I told? First A and second A. These are having highly electropositive, right? They have more electropositivity. First A and second A groups, elements. Examples also can continue here, like lithium hydride and calcium hydride. Lithium belongs to first A group and calcium belongs to second A group. Those hydrides are known as ionic hydrides, right? So that's about 14th question in the short answer type. Now 15th question is, explain the structure of diborane. Anyone can guess this, right? That is from P block elements, 13th group elements actually. 13th groups we have in the P block elements we have 13th group and 14th group, or 3rd A or 4th A group elements also they are known. Now this question, structure of diborane, the question has come from P block elements but 13th group. Okay. So the next question is structure of diborane is very, very important. We'll try to discuss in simple way. Structure of diborane. Actually, from the experiments, different experiments, they have decided one structure of diborane. First, I will draw that. From that, I will explain, right? What are those bonds and everything. So here, the structure of diborane will be like this: boron. Why? Because diborane formula is what? B2H6. Just now I told you that there is example for which hydrides? Electron deficient hydrides. Okay, B2H6. So two borons are there. And here, hydrogens. Total how many hydrogens are there? Total hydrogens, number of hydrogens are 6. Okay, H. Still here, hydrogens. Here one hydrogen. Here one hydrogen. Here one hydrogen. And here also one hydrogen. Right, B2H6. So this has come from different experiments, diborane. Here, I am writing here T, here also T, T, T. What about this? B. This one is B. Okay. This is what we are going to discuss. B for bridge, T for terminal, B for bridge, T for terminal hydrogen, B for bridge hydrogen. Okay. Actually, out of all the 6 hydrogens in the diagram, if you observe that, 4 hydrogens and 2 borons, all of them are present on the same plane. Here, boron is there, here also boron is there, hydrogens also on the same plane. That between borons, whatever the hydrogens are there, those one hydrogen will be above the plane, another hydrogen will be below the plane, both of them perpendicular to each other. Okay, these points we will write. So here, the two hydrogen atoms which are present in between boron atoms, right? Right. The two hydrogen atoms. So whatever I explained there, those only I am writing here, the two hydrogen atoms which are present, where they are present, two hydrogen atoms in between boron atoms, are known as, what are they called? I told HB means HB for bridge, so those are called as bridge hydrogens. Just we are explaining that structure. Okay, the next point is what about terminal hydrogens, right? So we can continue in this. And remaining four hydrogens are called T for, I told that what, terminal, are called terminal hydrogens. T for terminal hydrogens. Okay, these are terminal hydrogens, and the between the two boron atoms, those are called bridge hydrogens. So out of two hydrogen atoms, these terminal hydrogens, yeah, you can write the next point. Bridge hydrogens are placed perpendicular to the remaining borons, remaining two boron atoms, and four hydrogens. Try to understand that. Two boron atoms and four terminal hydrogens, all of them are present in the same plane, but two bridge hydrogens are, one is perpendicular, both of them are perpendicular to this plane. One is lying above the plane, that also we will write. So one HB means bridge hydrogen lies or placed above the plane, and another bridge hydrogen means HB lies below the plane. Just now I explained that. First, those two boron atoms and four terminal hydrogens, all of them are present on the same plane, and one will be above the plane, one hydrogen, and another one will be that below the plane. Okay, so here the very important point is hybridization of boron. Here how many bonds are there? 1, 2, 3, 4. All of them are sigma bonds, right? 4 sigma bonds means, according to Vesper theory, that undergoes which hybridization? sp3 hybridization. 1 s orbital, 3 p orbitals combined together to give 4 sp3 hybrid orbitals, right? In this, all the four, out of the four, yeah, we'll discuss later. Boron, each boron atom undergoes which hybridization? I told, undergoes 4 bonds are there, 4 sigma bonds are there. That is why it undergoes sp3 hybridization. And form 4 sp3 hybrid orbitals. who carries one electron each, right? Form 4 sp3 hybrid orbitals. Yeah, we can continue like not all of them. That is why 4 sp3 hybrid orbitals. We can continue. Out of 4 sp3 hybrid orbitals, out of 4 sp3 hybrid orbitals, 3 are containing 1 electron each. So each hybrid orbital is containing 1 electron. Means the remaining is what? Remaining was vacant. That is empty orbital. This is very, very important point. Out of 4, 3 are containing that 1 electron each. Remaining is vacant. So because of this, what will happen? Abnormal bonds will formed in between borons. Okay. Therefore, we can continue here. Therefore, the BHB bonds, this one BHB, here also BHB bonds are abnormal, means not normal, abnormal, which are known as three-centered. I will tell why we are calling this as three-centered 2-electron bond. Three-centered 2-electron bond, also known as banana bond. Okay. So from this you can say that each boron atom sp3 hybridization, and that is giving how many hybrid orbitals? 4 hybrid orbitals. And out of 4, each hybrid orbital containing what? 1 electron. Okay. So try to understand that. Here boron and here also boron. Each boron containing how many hybrid orbitals? 4. So I am taking here 1, 2, 3, 4. Here also 1, 2, 3, 4. So each boron containing 4 sp3 hybrid orbitals. And one more point is here, out of 4, 3 contains electrons, each one 1 electron. Here 1 electron, here 1 electron, here 1 electron. This one is vacant. That vacant one I am drawing like this, empty orbital. Okay. The same way here 1 electron, here 1 electron, here 1 electron. This one is empty. This is empty orbital. Got the point? So now how many hydrogens are there total? 6 hydrogens are there. Now I am writing the hydrogens. Hydrogen is having spherical structure, right? This is the hydrogen. We'll make one bond like this because hydrogen containing 1 electron, right? There is one bond. Here also hydrogen 1 electron. Same like that. Here also hydrogen with 1 electron. Here also hydrogen with 1 electron. So these 2 electrons are present here only in the overlapping of them, right? So overlapping. Each one having 2 electrons means what? There is normal bond, correct? One bond containing 2 electrons. If you observe here, the main thing here that here also hydrogen has 1 electron, right? This is hydrogen, this is also hydrogen. Each hydrogen is having 1 electron, correct? Here 1 electron is there, here also 1 electron is there. But here the point is, to make one bond, we require 2 electrons. But here 3 centers are there. One is boron, one is hydrogen, another one is one more boron. So here the bond is formed here. 1 electron of boron, 1 electron of hydrogen, and empty orbital of another boron. Correct? Here also 1 electron of boron, empty orbital of boron, and another electron of boron. Right? Yeah, electron of hydrogen, sorry. Hydrogen of electron, hydrogen, electron of hydrogen, electron of boron, and empty orbital of another boron. 3 centers are there. All the 3 are sharing only 2 electrons, right? That is why this bond is known as, we wrote here, 3-centered 2-electron bond. 3-centered 2-electron bond. Okay. So finally, you can write this. You can write boron structure, which are equal. So here hydrogen, here also hydrogen. All the 4 are normal bonds, not abnormal bonds. The between the bonds which are present in the 2 borons are abnormal bonds, correct? Here the bond will become like this. Here also bond will be like this. What is there here? Hydrogen only. So the shape of that bond is just like banana, right? Correct or not? Just like banana. That is why that called as banana bond, and also called tau bond. So better to write these points to get full marks. Very simple. If you try to understand this, definitely we can write that as it is. Okay. At least try to draw these 2 structures. Okay. Even you draw this also, very good. So that is the point. That is about the 15th question about structure of diborane. We'll go for next topic. Next question, 16th question is, that 16th question has come from 14th group elements. 13th group elements, we got this diborane. From 14th group elements, one more question. So we know that in the 14th group elements, most of the times they will ask you about allotropes of carbon, the difference between diamond and graphite. And sometimes they ask you that why graphite is a good conductor, correct? That question also will come. Why graphite is used as lubricant? Why diamond is hard? These questions will come most of the times. Sometimes they may ask you the definitions also. So in this time, in this model paper, he asked that, what do you understand by allotropy? Okay, allotropy. And one more question has come from inert pair effect. So usually people learn this for 2 marks. Those 2 marks combinedly give as 4 marks. Okay, let us discuss that. 16th question. What do you understand by allotropy? First, allotropy. Allotropy. So here, allotropy means the elements, the phenomenon of same element exist in different forms is called allotropy. Very simple. Okay, exist in different forms, same element. You can take the example, twins example. Both of them looking alike, but the properties are different. In both of them, one of them like vegetarian food, another one may be like non-vegetarian food. One may like one hero and another may like another hero or heroine, right? One may like one subject, another may like another subject. Means what? Both of them looking same, but properties are different. So allotropy means the phenomenon of existence, the phenomenon of existing the same element in different forms is called allotropy. Simply you can write that the phenomenon of existence or exist, the phenomenon of exist of same element in different forms, same element in different forms is known as allotropy. We know that already, the allotropes of carbon, just now I told you in the introduction, diamond, graphite, both of them are carbon only. Even coal also, charcoal also. All of them containing carbon only, correct? But the properties are different. The phenomenon of existing the same element in different forms. Existing the same element in different forms is known as allotropy. Example you can take, just how I told you that carbon is containing how many types of allotropes? 2 types. Example, carbon contains 2 types of allotropes. 2 types of allotropes. What are those 2 types of allotropes? Why we are writing this means he asked that what do you understand from the following. So we have to write that examples also, then only we will get the marks. Carbon contains 2 types of allotropes. What are those? Crystalline forms, amorphous forms. Okay, one is crystalline forms. Another one is amorphous forms. Two different forms I wrote that, crystalline forms and amorphous forms. Example for crystalline forms is what again? Example, you can say that diamond and graphite. Here example is what I told you just now, coal, charcoal, etc. Okay, and one more point also you can include in this. One more form, third form also is there. The third form of carbon is called what? You can also write that the third form of carbon is called, what is that famous, that also? Fullerene. Okay, third form of that carbon is called what? Fullerene. Okay, this one, allotropy. One more given that A is allotropy, B is inert pair effect. Okay, inert means inactive. Okay, inert pair is one pair is inactive. Which pair? That is electron pair. It is present in the s orbital. Okay, so those 2 electrons or the pair of electrons will show not interest to participate in the bonding. That word we are using, that reluctance. The reluctance of NS electrons to participate in bonding is known as inert pair effect. If you take lead or tin, whatever, the outermost configuration is what? NS2 NP2, because that is 4th group. Here either lead or tin, both of them having 4 electrons to lose, but they will lose only 2 electrons. The electrons which are present in the p orbital only they will use. The electrons which are present in the s orbital will not show interest to participate in the bonding. They don't have interest to participate in the bonding. That phenomenon is called inert pair effect. Okay, so let's write the definition. How can you write this? The reluctance, that word you have to use, or not interest, you may say in any way. The reluctance of which electrons? NS electrons. The reluctance of NS electrons participating in bond formation. So in the bond formation, to participate in the bond formation, they don't have interest in bond formation. That is called inert pair effect. Okay, they are not showing interest to participate in the bonding. That is called as inert pair effect. So even though lead and tin have 4 electrons, they show +2 oxidation state instead of 4 +4. Okay, so example you can write that lead and tin show +2 oxidation state, +2 oxidation state due to what? Due to inert pair effect, due to inert pair effect. Because inert pair effect means those two electrons which are present in the ns orbital, those are not having any interest to participate in the bonding. That is why those will not lose all the 4 electrons and will not form +4 oxidation state. They will form only +2 oxidation state. Okay, that's about 16th question. We'll go for the next 17th question. So that 17th and 18th questions, 17th and 18th questions have come from organic chemistry. Okay, from organic chemistry they have given. First 17th question. 17th question he asked that describe any two methods of preparation of ethane. And we know that ethane, ethene, ethane, all the three are very, very important, right? That is acetylene, ethylene and ethane. He asked now in this model paper that preparation of ethane, two methods, right? So methods of, he is asking that methods of preparation, methods of preparation of, methods of preparation of ethane. Okay, methods of preparation of ethane. Two methods we have to discuss. Okay, the first method, very simple methods we will try to discuss. Two methods of preparation of ethane. The first method I am taking that decarboxylation. Okay, the first method I am taking that decarboxylation. Decarboxylation. So which we have to take for decarboxylation? Decarboxylation means removal of carbon dioxide from salts of carboxylic acid. Salts of carboxylic acid. From the salts of carboxylic acids, we have to remove carbon dioxide. That is called decarboxylation, right? So we will take to get ethane. So we can say that to get ethane, we have to take which is having 3 carbons. The salt which is having 3 carbons, because one is eliminated in the form of carbon dioxide. So you can say that by heating sodium propanoate, by heating sodium propanoate. Prop means what? 3 carbons. Okay, ethane containing 2 carbons. So 1 carbon will be removed as carbon dioxide. So we'll get only 2, right? That is the point we are taking this. By heating sodium propanoate in the presence of, what is that? Soda lime. In the presence of soda lime. Soda lime is what? Soda lime is a mixture of, soda lime is a mixture of NaOH and CaO. By heating sodium propanoate in the presence of soda lime gives ethane. Okay, the statement is this. Based on the statement, we can write the equation. Okay, whenever you are learning the organic chemistry, you may learn either statement or equation. One you got means another one automatically you can write. Okay, so sodium propanoate means 3 carbons are there, CH3, CH2, COONA. This is called sodium propanoate. Okay, sodium propanoate. So this is reacting with what? Soda lime. What is that? NaOH. NaOH and CaO, calcium oxide, and we are heating that. What I told here, we have to remove the carbon dioxide. That carbon dioxide will be removed like this. Na2CO3. Na2CO3. 1, 2, 3. This H will attack here. Then what will come? Our required product will come, that is ethane. CH3, CH3. What we removed? That Na2CO3. Sodium carbonate we removed. Ethane. This is the first preparation. We got ethane, right? Very simply. Just we are heating with soda lime. We removed that carbon dioxide. Carbon dioxide means carbon dioxide in the form of sodium carbonate. Okay, separately. Minus CO2 you can also write. Okay. The next one, second one is Wood's reaction. Wood's reaction. So these questions may not come as it is. These questions may not come as it is in the main exam. Right? But here they may give you that from these 4 marks, they may give 2 marks. What is decarboxylation or what is Wood's reaction? Okay. 4 marks may come in the form of 2 marks. 2 marks may come in the form of 4 marks. 8 marks also may come from 4 marks or 2 marks, like that. Anyway, if you learn them, definitely you may get marks. Okay. So the next one is by heating. Here Wood's reaction is by heating methyl iodide. Methyl iodide in the methyl iodide with sodium metal. Okay, with sodium in the presence of dry ether. In the presence of dry ether, we have to take that dry ether as solvent and we have to take sodium metal, then you will get ethane. So how we are going to get, we will discuss. Methyl iodide means CH3I. We have to take 2 moles of that CH3I. Methyl iodide. The name of this is methyl iodide. So we have to heat that. What we have to take? Sodium. Sodium I am taking. 2 iodines are there. There is 2 sodiums I have taken. Okay. Then we have to heat this in the presence of what? Dry ether. Dry ether. So what can we remove from this? Here CH3I plus Na plus ICH3. This we have to remove. Okay. Of course, here bonds are there. CH3I. Okay. Remaining part is what? Remaining part is CH3, CH3. Required. Remaining is what? 2NaI. What is this? Ethane. We got ethane. Finished. So these are the 2 methods of preparation of ethane. One is decarboxylation, another one is Wood's reaction. Very, very simple reactions. If you practice, you will get them easily. Okay. That's about 17th question. And as I told you that 18th question also came from organic chemistry, because organic chemistry definitely 8 marks. They may be 4 plus 4 or 1 8 marks. So in this model paper, they have given the 2 4 marks questions, and anyway you get 8 marks. And of course, we discuss in the 2 marks also IUPAC nomenclature. The last question in this section is write the reactions of ethylene. So from ethane 1 question has come for 4 marks. Ethylene also 1 question has come. Write the reactions of ethylene with the following. Okay. Reactions of ethylene. Last questions. Reactions of ethylene. Reactions of ethylene. So he gave, what are those? He gave that one is ozone. He given that one is ozone. Reaction with ozone. Ethylene reacting with ozone, what will happen? Okay. And one more, ethylene reacts with cold dilute and alkali KMnO4, potassium permanganate. So when ethylene reacts with these two reagents, what will happen? That is the question. Okay, write the reactions of ethylene with the following. So what will happen? First one, ozone. Reaction with ozone. Reaction with ozone. With ozone, which one is reacting? Ethylene. So ethylene reaction with ozone. That is the question. That is the point. So ethylene, we have to take that CH2 double bond CH2. This is called ethylene. Correct? Ethylene reacting with ozone plus O3. First, we will get that CH2, CH2, and here one oxygen, here one oxygen, here one oxygen. Okay, this is called ethylene ozonoid. This is called ethylene ozonoid, which undergoes hydrolysis in the presence of zinc. Then it will give CH2O. Okay, try to understand this. Reaction with ozone is called as ozonolysis. Don't get confused. This is called ozonolysis. This is what ethylene. This is what ozone. This is what I told, ethylene ozonoid. Ethylene ozonoid. So when it reacts with ozone, it is forming ethylene ozonoid, and it undergoes hydrolysis in the presence of zinc to give formaldehyde. CH2O means what? Formaldehyde. That is the statement. You may write the statement also based on this. Here this bond will break, this bond will break, and this bond also will break. This CH2O, here one CH2O, both will come as 2 CH2O. Here one CH2O, here one CH2O. Correct? How can you write the statement? He asked that reactions only. You may write the statement also to get the impression, right? Ethylene reacts with ozone to give ethylene ozonoid, which undergoes hydrolysis in the presence of zinc to give formaldehyde. Finish. That is the statement. By seeing that equation only, you can write the statement. And this total reaction is also named as what? Ozonolysis. Okay. And the second one, he given that reaction with cold dilute alkali potassium permanganate. Okay, this is the next one. This cold alkali dilute KMnO4 usually called as Bayer's reagent. That is why this reaction is known as Bayer's test. Okay, this is all extra information only. Even you may not write, also will get the marks, of course. Okay, Bayer's test, because that reagent is called as Bayer's reagent. Now, what will happen if they react with Bayer's reagent? CH2, that is what? Ethylene reacting with KMnO4. Directly you can write that potassium permanganate will give that, of course, cold dilute alkali KMnO4. It will give product which is known as ethylene glycol. Here one OH and here one OH will come. Okay. So ethylene reacts with cold dilute alkali KMnO4 to give ethylene glycol. That is the statement. Very simple. This is ethylene. So ethylene reacts with cold dilute alkali KMnO4 is what? Potassium permanganate. Potassium permanganate. To give what? What is the product we got? This is called ethylene glycol. Ethylene glycol. So you can say that finally, ethylene reacts with cold dilute alkali KMnO4 to give ethylene glycol. This test also known as Bayer's test. Why? Because reagent is known as Bayer's reagent. Okay, that's about section B. 4 marks short answer questions.